Next speaker is Lex, and he's talking on Blaze, crunching data in different formats through one API.
Hi there. Can everyone hear me okay? Yep. Great. Okay. So, as we spoke about, I'm going to talk about a technology called Blaze. And at the start of the morning, Graham kind of gave a bit of an overview of the scientific Python sort of landscape as it stands kind of now, and interesting things on the horizon. And I think sort of Blaze is another one that's kind of on the horizon that's quite interesting to have a look at. So we'll give you guys a bit of an idea of that in the next half hour or so. So yeah, my name's Lex. I've worked professionally in Python and data for the last sort of 4 or so years ago. That's where you can find me on GitHub and Twitter. The slides are up online, and I might sort of tweak them a bit after the talk when we're done. So who is Blaze for? So if I could just briefly poll the audience. Who would say that they're a programmer or a coder first, and that you might have studied computer science, or that's kind of your main day job, and that sort of your data science component is secondary to that? Put your hand up if you would put yourself in that category. That's probably a fair majority, I would actually say. And who would say the other way around, that they're kind of a scientist or a data person, and then they program to get to what they want to do? Oh, it was probably more than that. It's probably almost half-half, maybe 60-40 or something. I'm not exactly sure. Yeah, I'd say 50-50 then. So really, I would say that for people in that second audience, which is you're a data person who programs to get what they need, that you're the biggest audience for something like Blaze. In a nutshell, the sort of TLDR is it allows you to sort of use a pandas-like API on different backends, though. So you can talk to a SQL database, MongoDB, CSVs, all that kind of thing. But it makes it really easy. And so something that it might allow you to do is prototype on your laptop, using a CSV with a few hundred lines or a few thousand lines, and then deploy when you actually need to run your solution on something like Redshift or Postgres or whatever it may be, using the exact same code. And sort of one of the key sort of ideas behind it is that it's optimized for people, not necessarily for, damn it. For people, not for performance. Sorry. Okay, apologies. I just have to keep pressing a button every couple of seconds. Yeah, so I'd say that the biggest people are going to have a win from this is people who code as second, data people first. You might already know pandas, or pandas is quite often one of the first ways of kind of getting your heads around that kind of thing. Does anyone, when I'm talking about pandas, is there anyone in the audience that hasn't got some familiarity with that, hasn't used it before? Are we all on the same page? Okay, so I guess there's a few ways of talking about that. One is sort of, for those people who may be familiar with something like R, essentially pandas is R for Python people. If you're not familiar with that, pandas is like a spreadsheet on steroids. or if you're a database person, pandas is like a SQL table, but again in Python are quite nice, and so lots of data things are happening with pandas being behind the scenes, and it allows you to kind of express your data really elegantly. So essentially what it gives you is a 2D data structure that's just like, think of it like a spreadsheet, and it allows you to think about your data at a higher level of abstraction. I gave a talk at this exact same mini-conf last year. It's online at YouTube, 45 minutes. If you're one of those people who haven't heard about it before, go have a look. I think I sort of gave a pretty good sort of half-hour, 45-minute intro onto that, so maybe check that out. Okay. So why Python? So I'm obviously speaking to the choir, but people might talk about the elegant code or the libraries that exist. My answer to that one is because I'm lazy. Because when you're writing Python code and using some of the libraries, it feels like you're cheating. And I think kind of once you've got your head around Blaze a little bit, it's sort of the same kind of idea. Oh no, what's going on? Sorry, a few technical problems. I'm just going to switch browsers. Okay, that's better. Apologies. Why pandas? Because it really lets you succinctly kind of explain what you're trying to do. So here we have a data frame, and we want to calculate who are cool people. And really, laziness is a virtue, and as I said, with a lot of people here who aren't, software people first, you want to spend as least amount of time reading API documentation and more time looking and playing with your data. So a bit of a background with Blaze. There's a company called Continuum.io. One of the big people behind that is a guy called Travis Oliphant. If you haven't heard of him, he's sort of one of the initial authors of NumPy. And the same company, Continuum.io, is also behind some other technologies like Bokeh, which is a graphing library, and also Anaconda. They were given a $3 million DARPA grant back in 2013 to work on some of this data stuff. And so sort of, I think most of what I'm going to speak about has sort of come out of that, as well as a few other projects. And so really, even though the title of my talk is about Blaze, really that's kind of been split into kind of a few different sub-projects. So I'm going to talk about essentially 3 different things that are all kind of closely interrelated. So we'll get into the details of each of these as we go along, but one is called Odo. One is called DataShape, and one is called Blaze. And we might touch on Blaze Server at the very end if we have some extra time. And so if we cover those libraries and what problems that they're solving, so we've touched on Blaze, and really it gives you a pandas-like API to query your data or munge your data. We have Odo, which can easily move your data between different formats. Odo can also easily move your data from place to place for you. And we have data shape, which is sort of a technology agnostic way of describing, what kind of format your data looks like. And another thing that Blaze can do is it's got some technology there where it can do things like process a data set that's, say a CSV that's larger than the RAM in your laptop. Okay, so moving on to Odo. And again, speaking to the programmer's second crowd, databases. I only know Excel. I don't want to know databases. SQL, I've learnt some pandas. I've got that under my belt. Now I have to learn a whole other language to do what I want. JSON, what's that? AWS, S3, Bodo. These are all, more things for you to learn. So by learning Odo, it kind of means that you may not have to, or you at least can postpone having to learn the details of some of these things. So for all the things that I'm speaking about, this is how you install it. You can use either conda or pip install Blaze, and these other libraries that I'm talking about, they'll be put in as dependencies. I'm giving another talk on Sunday about Conda and Anaconda. If you're interested, come have a look at that one. It should be good. Okay, so we have a function called Odo. It's very simple. Odo is given a source and a target, and it will take the source and put it where you tell it that the target is. And so with the example here, we're giving it a pandas data frame, and we're saying, put that in a CSV file. So as well as being a Python function, there's also a command line interface tool that gets installed with that install called Odo. So this example here is loading all the CSVs in this directory that start with data 2015, and it's going to store it into a SQLite database. So you can see from the SQLite example there that essentially what you pass into Odo is these things that look like URLs, and it figures out what that refers to. So I'm just going to load this up. I'm not expecting that you'll be able to see anything on this graph, but you can see that it's a big graph, which is really all I want you to see. If we go into it, we might see some things that we recognize. We can see a pandas data frame. We can see a CSV on S3. There's some JSON. What else have we got? We've got some SSH. Date time. So really when we're talking about it moving data around and converting it, under the hood what it's doing when you say, okay, give me, I have it in this format, give it to me over here, is it figures out the best path to use along this graph with the least cost. And the cost is the performance. How fast can it do that? Okay, so we're just going to go through a number of examples, and it'll give you some of the ideas of some of the things that Odo can do. So you can load up my CSV into a data frame. You can save my CSV into different databases, SQLite, Postgres. Again, for people who aren't familiar, with databases have a common language that you query them with called SQL. Technology been around since the 70s, and there's different sort of varieties of databases. There's some of the more popular ones being SQLite, which is really easy to get started with, and you can run it easily on your laptop. Postgres is probably, the people in the Django room next door will, be able to tell you that's the one to use for open source databases. There's Microsoft SQL Server, and then a lot of these big big data cluster type things will quite often have a SQL interface to them as well. So here we can save our CSV into a database, or we can read from a database and get a CSV without having to know any details whatsoever. We can give it multiple files, and it joins them all up together, and we can give it compressed files as well. It knows JSON as well as CSVs. So again, I can be given a JSON file, load it into the database, or vice versa. And we can see here that it gives us a few different options on what our JSON might look like. And just to give you reiterate what Odo is doing, if you are someone who is familiar with pandas and what it can do, you might think, okay, I can read in a CSV into pandas and then save it into SQL with a couple of lines of pandas code. Especially there's some in the docs it talks about, especially with SQL and CSVs, is it can use the fastest possible thing built into the database. So it's going to use the features built into the database that allow you to load up gigabytes worth of data as fast as it can. And under the hood, it's using SQL Alchemy. So anything that SQL Alchemy can do, Odo can do. For people, again, who don't know a lot about databases, you've got all these different types of databases that are very similar, but just a little bit different. SQL Alchemy is a Python library that kind of abstracts that away for you, so you can not have to worry about those differences so much. So that was really about changing formats and moving it around. It can also move it up on S3 for you. That's somewhere on Amazon's cloud that can store your data for you. So you can read it from S3, or you can upload it to S3, again with a single line. I'm missing a bracket there, apologies. Or if you need to download your file from another server first, it can handle that for you as well. So it can SSH onto a server and download it, or copy it across for you quite easily. So it can do quite a lot, and it's easily extendable. These are all different formats that it knows about at the moment and can handle. But it's not this massive library that knows about all these different data formats. It just calls out to the best library that kind of exists. So if it's reading in a CSV, it's going to do pandas.read CSV, and if you need to be a bit more precise about how you want the data read in, then you can pass in some keyword arguments, and that'll get passed to the underlying method. So we've talked about Odo, which is essentially copy from here to here, change the format if need be, or read it into a variable that I want. You can also drop it. So if you've copied it from somewhere and you don't need it anymore, you can say, okay, get rid of it, drop, just database speak for delete. So one thing you may have noticed though with we're only passing these two things, which is my CSV, put it into the database. How does it know what format to give each column of my data? How do I tell it that it's a date and not a string in the sign update column? And that's where data shape comes in. So we have a few things that already exist that kind of talk about, okay, here's the structure of my data, here are the columns, here's the types of my columns. We have SQL schemas, we have pandas D types. And what data shape essentially does is kind of abstracts away those ideas into kind of a higher level abstraction. So essentially what you do is you create a string that describes what your data looks like and what the types are. So really the second line on that slide is really all you need to know to get going, which is the var star is just saying there's going to be, could be any number of rows. There could be 10, 100, 1,000. There's 3 columns, name, joined, and credit. And in turn, that name is a string, joined is a date time, and credit is a decimal number. If you do want to be more precise, and it's there's going to be 10 rows, you can specify that as well. But that's what you do. Different backends perform better if you can tell it how long the biggest string can be, so you can specify that. And if you give it a question mark at the beginning of the type, then it means this can be an empty value, it can be null. So now our example, we can say, okay, here's what the data types are, and this way we'll end up with a database column that fits what our data is. Yeah, so I'm going to talk about 3 libraries in this talk. One was Odo, which we've covered, which is moving your data around and changing formats for you, and data shape that helps you abstractly say what your data looks like. And what Blaze does is let you sort of separate what you want to calculate from what your data is, and to be able to do that with an API that looks like pandas. And you do that by building expressions. It'll only calculate when it needs to. And once you've built your expression, you can switch the back end seamlessly. So you can develop on a CSV, and then you can run it on a database or wherever else that is supported. So see, these are some of the backends that currently exist. So it can work in pure Python, you can just lists and iterators. It can use pandas. It's got quite a few smarts around some pandas things that it can do, where it can do it in a chunked fashion. So for example, I've got 100 CSVs and I want to know the sum of the transaction amount column for all of them. I can just sort of, in one line or in a couple of lines, tell it the calculation. What it will do is it'll read each one in turn, calculate the sum of each one, keep track of all that, sum them all together to get the grand sum, and it'll do that without having to eat up all your memory necessarily. It can do SQL, so without having to know SQL, you can communicate and do a lot of stuff that you would do in a normal database. So if you do a bit of research after this talk and find some of the blog posts by the author, so I should give a shout out. I think the main author of this project is a guy called Matthew Rocklin, and there's a few interesting blog posts. One is an example where they've got the exact same data set in different formats, and they're running it on these different formats and seeing what the speed up is. And so he writes his calculation once, what he wants to figure out, and then he just switches backends and sees how much faster it would be if he had it in a Mongo database instead of a CSV on his laptop, or if he put it onto SQLite, or let's say he's got it in his database and, damn it. Sorry. I think it's going to come back. The other thing you can do when you switch backends is you can do things like add a database index on specific columns that might make sense, and it will figure that out for you. That might make a big performance difference. And just a note, my first example is going to be kind of quite explicit about saying, okay, here's what the types are in the columns, but there's a lot of sort of smarts here where it can figure that out for you, and if it guesses it wrong, you can sort of tweak it, but you don't have to kind of be so explicit in saying all of that. So people who know some pandas, this should look pretty familiar. So we create our accounts object here, which is kind of, that's our data set. And it's a data set that we're calling it accounts. It has this D shape, data shape, which is any number of rows with an ID, which is an integer, a name, which is a string, and an amount, again, which is an integer. And we're calculating cool people, which is people with the name Lex. And just to kind of highlight that this hasn't calculated anything. This is just saying this is an expression. This is a calculation that we're going to run on some data set that you haven't seen yet. So let's run it against a pure Python list. Here's our data set. It's got some IDs, some names, and some amounts. And so everything happens with this compute function. We say give compute our expression and our data set, and it'll figure out by which type of data set that I give it, whether or not to use Python code, pandas code, SQL code, etc. And so you can see here it's figured out the result, and I've wrapped it there in a list because otherwise it's going to return me an iterator. So now we can run our calculation on any native backend that we choose. We can run it in pandas, we can run it against a SQL database, a mongodb database, all those backends that we spoke about. So here's some more examples. We're running the exact same calculation, but now it's running in pandas. And then we've got another example. We just load up our database, and this looks like it's pandas or sort of NumPy code, but under the hood, what that's going to do is connect to the database and give it a SQL query. And if you've got lots of database, or you've got a powerful database server and a crappy laptop, that could be, much, much faster perhaps than the alternatives. So now you know what your API, you can use your sort of pandas-like API on any backend. Now all you need to do is learn the API, which if you know pandas, you almost do. It's like a little bit different in some places, but it's essentially the same. If you check out these two links, it gives a really good overview of for people who already know either pandas or SQL, how to do some things in Blaze. I'll give you a quick highlight of those and then wrap it up. So these are some of the main ones. You've got by, which is for doing essentially group by operations. You've got join for joining different data sets on a particular column. And just before I go over that, some other smart things that this technology do that I'm not really going to be able to cover in depth is, I've kind of touched on the first one. It can sort of chunk your data and be a bit intelligent about doing that for larger data sets. It can use Dask, which is a new sort of fancy pants NumPy out of core technology. And it does have some things where it can parallelize your code. So here we're calling the map function, and if we first create this multi-processing pool, then it's going to run it over multiple cores. I should call out though that these things aren't magic silver bullets where it's going to speed up every situation, but in particular cases it might make a big difference. So this looks identical to pandas. You can refer to a column as either like a dictionary type or as an attribute. You can do maths inline. You can call the map function. This is how you do a group by. So here we're grouping by person, what was their total amount spent, what was their average amount spent. We can add new columns derived from other columns. So you could do a ratio between columns. Here I've got the amount in cents by just timesing it by 100. And so amended now has a new column in it that accounts didn't. We can rename our columns. This is doing some string matching. It's matching where star Lex. We can join them together. I think I've covered that enough. So I haven't got time to go over Blaze server. Check it out. It allows you to create a server that then allows other people to connect to it and interface it just by writing Blaze code essentially. So if I wrap up, when I first heard about this, I thought it was quite exciting technology, and I've spent a lot of time kind of learning those libraries that I said that the non-coded people don't have to, and now maybe I can forget them and just use this stuff. But yeah, this isn't a magic bullet, but at the moment it can really only do the things that all those technologies can do in common. However, I think that in many cases can get you an awful long way. It's not the answer to every problem, but at work, I deal with sort of analysts who aren't programmers, but they know Excel, and you think about, okay, should I teach them some Python? Should I teach them some pandas? Should I teach them some SQL? How should we get them using some more powerful tools? I think if you use this technology, you can teach them Blaze and pandas, and they can interface through SQL or data on S3 really easily. I think it might be a nice idea if pandas could adopt some of the APIs, which I think some of them are a little bit nicer than pandas, but even though they're very similar, and separating your data from your computation is a good idea. And the docs are really good. Questions?